let's recap the things we talked about in the section that came right before this. So in that section, we learned that congruent chords have congruent arcs. So if you know the two chords are equal, you know the two arcs that go with those chords are equal. Okay, got that down. The next thing that we learned was if a diameter is perpendicular to a chord, it will bisect the chord and bisect the arc. So it divides the chord into two equal parts, and it divides the arc into two equal parts. Any diameter that is perpendicular to a chord. And the last thing that we learned was when we have two chord segments that cross inside of a circle, then the pattern we follow is first part of the one chord times the second part of that same chord will equal the first part of the other chord times the second part of that other chord. Today we're going to talk about a new segment. We're going to talk about secant segments. Now, a secant, recall, was a line that intersected a circle at 2 points. So a secant segment is a piece of this line. And for secant segments, we actually take the outside, that's the part outside of the circle, like the G here, times the whole length on one secant segment will equal the outside times the whole length on the other secant segment. So outside times whole equals outside times whole. Let's take a look at an example of this. So if you look here, in number 1, we have secant segments. When you have secant segments, the pattern you think of is outside times whole length equals outside times whole length. And I would encourage you to first label the whole lengths. For example, on this top secant segment, R to P, the whole length would be all of this together. So it's going to be 12 plus 3. So the whole length there is 15. On that segment then, the outside is 3, and the whole length is 15. So we will take 3 times 15. On the other secant segment, this whole length right here will be x plus 4. So the outside is the x times the whole length, which is x plus 4. And that's what we have to solve. This, of course, is going to require some algebra. So let's go ahead and do the algebra. When we take 3 times 15, we get 45. On the other side, we'll distribute x squared plus 4x. We have to get 0 on one side, so we subtract 45. And then we're going to solve it by using factoring. Factoring was one of the algebra skills that we reviewed. When we factor that, we'll need x and x in the front. Then we need things that multiply to give us 45 and subtract to give us 4. Looks like we're going to have to use a 5 and a 9. To get a positive 4, we need a positive 9 and a negative 5. And all of that's equal to 0. Now we set each of those factors equal to 0. This one we add 5. We get x equals 5. This one we subtract 9. We get x equals negative 9. Now the negative number will not work in this problem. And that's because lengths can't be negative. So it's very important that we box our answer. And once again, you must box your answer. Let's try a second problem. So in this second problem, we once again have secant segments. So we once again follow the pattern of outside times whole equals outside times whole. It doesn't matter which one you do first. This time, let's work with this bottom one. On the bottom one, this whole length right there will be x plus 5. So the outside is 5, and the whole length is x plus 5. On the top one, right there, the whole length will be 15. 9 plus 6 is 15. So we'll take 6 times 15. And we must work it out. Distributing the 5, we get 5x plus 25. 6 times 15 is 90. Subtract the 25 on both sides, we have 5x equals 65. Divide by 5, we end up with 13. And again, you must box your answers. Let's take a look at a third problem involving these secant segments. So yet again, we have secant segments. So our pattern is going to be outside times whole equals outside times whole. Now let's talk about this one as our first secant segment. For the whole length, we'll have to take 3 plus x plus 2, which is really just 5 plus x. So on that one, the outside is 3, and the whole is 5 plus x. On the bottom one, right here, we need the whole length. The whole length is going to be x plus 1 plus x minus 1. Well, that's just 2x. So we have the outside, which is x plus 1 times 2x. Now comes the algebra. 3 times 5, 15. 3 times x, 3x. 2x times x, 2x squared. 2x times 1, 2x. We're going to move everything to the right side to go ahead and solve this. So I'm going to move that over and move that over. I get 0 equals 2x squared minus x minus 15. And yet again, we're going to factor. When we factor this, we end up with Well, to get 2x squared, I have to use 2x and x. And then to get 15, and I have to subtract to get 1, I'm going to need to use a 5 here and a 3 there. On the outside, I'd have 6x, and the inside, I'd get 5x. That does subtract to give me 1x. I want a negative 1x, so I put a negative here and a positive there. I set each of those factors equal to 0. This one I'll have to subtract 5 and divide by 2. This one I just add 3. And again, this one does not apply here. Can't have a negative length. So this is my answer. And again, you must box your answers. If you don't, we'll take that to mean that none of them are actually answers. Let's try a fourth one of these. So yet again, we have this secant segment situation. So yet again, we use outside times whole length equals outside times whole length. And I strongly encourage you to label the whole lengths. So right here, that whole length will be 22 plus 18, which is 40. Oops. Don't want to use the highlighter there. So I'll be taking 18 times 40 equals, on the other secant segment down here, the whole length will be 29 plus x. So I'll be taking x times 29 plus x. And now comes the algebra. 18 times 40 is 720. Distributing, we get 29x plus x squared. We have to move everything over to get 0 on one side. So x squared plus 29x minus 720. And yet again, we'll factor. When we factor, to get x squared, we need x and x. Now to get 720, we're going to need numbers that multiply to give us 720 and subtract to give us 29. We're going to have to use 45 and 16. And to get a positive 29, I'll need a positive there and a negative there. I set each of those two factors equal to 0. Subtracting, I get negative 45. Adding, I get 16. The only answer that works here is 16. This one does not work here. And again, you must box your answers. Now that one was pretty hard to factor. So take a look at that one, see if you still have a question on it. Let's take a look at another one. This one's in the form of an application problem. It's still a secant segment problem. We're still going to follow the pattern of outside times whole will equal outside times whole. Now it says you need to be within range of a cell tower to make an emergency call for assistance, so you have to be inside the blue circle. Your ATV is broken down at point A. How far do you have to walk along the trail? How far is X to finally be within the cell range of that tower? Now, before we proceed, let's go ahead and find our total lengths. So along this one, the whole will be 42 plus 38, which is 80. And then along that bottom one, the whole will be 23 plus x, so x plus 23. Now let's go ahead and set it up. And I'm going to put this bottom one first. So when I put the bottom one first, I have the outside, which is x, times the x plus 23. And then the outside of the top one is 42, and the whole length we determined was 80. Doing the algebra, x squared plus 23x equals, and that works out to be 3,360. We have to move that over to the other side. Now, this one does not factor, so we have to use yet another skill that we reviewed back in the beginning of this chapter. And the skill that we're going to use is we're going to use the quadratic formula. Now, the quadratic formula was the x equals negative b plus or minus the square root b squared minus 4ac all over 2a. In our problem, we can see what the a and the b and the c are. So let's just write those down. The a would be 1, the b would be 23, and the c would be negative 3360. If I put that into the quadratic formula, I'll have x equals negative of b plus or minus the square root of the b squared minus 4 times the a times the c. And that entire thing, including the negative b, is divided by 2 times the a. That actually will give us, if we simplify what's under the radical sign, radical means the square root sign, underneath that square root sign, we have 13,969. And from this, we have two possibilities. It could be that we use the negative sign. So negative 23 minus the square root, 13,969. All of that divided by 2, or it could be we use the positive sign. Negative 23 plus the square root, 13,969 divided by 2. Now it told us that we're going to round to the nearest mile. So in the problem it said round to the nearest mile. When we put this into our calculators, it's very important you put a parenthesis around the whole top. And if we do that on the top one, we end up with x equals negative 71. If we do that on the bottom one, we end up with x equals 48. Now, this one does not work because you can't have a negative distance. So this one has to be our answer. So we must travel 48 miles. And yes, you will have to know the quadratic formula, and yes, you'll have to be able to use it on quizzes and tests. Now take a look at this one. Pretty involved, quite a bit of algebra, but remember for secant segments, the pattern you have to learn and follow is outside times whole length equals outside times whole length. Good luck on the practice. Remember the help times are available, and I'll see you when you